Good day to all. I am Jenny Rose A. Cabohok from BPED 1B. In this video, I am going to discuss my assigned topic under the Environmental Science Ecosystem, which is energy and its flow on ecosystem. As we all know, ecosystem is the biological community of interacting organisms and their physical environment. So what is energy? So, energy defined as the capacity to do work, whether that work be on a gross scale as raising mountains and moving air masses over continents, or on a small scale such as transmitting a nerve impulse from one cell to another. Energy is the ability to work, which is when a force applied to an object, it moves. Energy can be found in any number of forms. For example, when you eat, the body breaks down the food and the food gives you an energy. Energy works in our body. So there are two kinds of energy: the potential energy and the kinetic energy. So what is the difference between the two? Between the two. So potential energy is the energy at rest. It is capable and available for work, while kinetic energy is due to motion and results in work that the results from the expenditure of energy can be two kinds. Can be stored energy as potential energy, and it can be ordered matter without storing energy. A rubber band. For example, rubber bands can be classified as both potential and kinetic energy, depending on the state of the band. When an elastic band is stretched, it's located with potential energy. When releases, there is the shift to kinetic energy. Another example for kinetic energy: the movements of planet. The movements of planet around the sun and the other stars in the galaxy is kinetic energy at work, as they are drawn towards the large object at the center of their respective orbits. Due to the strong gravitational pull, they fall towards the center of the mass. Energy has two laws of thermodynamics. The first one is the law of conservation of energy, and the second one is the law of decrease in energy. But before anything else, let me define first the first law of thermodynamics, which is the law of conservation of energy. In the law of conservation of energy, it states that energy is neither created nor destroyed. It may change forms, pass from one place to another, or not upon matter in various ways. In this process, no gain or loss in the total energy occurs. Energy is simply transferred from one form or place to another. So there are two reactions in the conservation of energy. The first one is the exothermic reaction, and the second one is the endothermic reaction. In exothermic reaction, when a wood is burned, the potential energy present in the molecules of the wood equal to the kinetic energy release, and heat is evolved to the surroundings. The chemical reaction that involves the release of energy in the form of heat or light. While in endothermic reaction, the energy from the surrounding may be passed into a reaction. Any chemical reaction that absorbs heat from its environment. Then let's move to the second law of thermodynamics. The law of decrease in energy. In this second law of thermodynamics, it relies on entropy. Entropy is a measure of disorder of an ecosystem. One of the examples in this second law is that when a coal is burned in a boiler to produce steam, some of the energy is dispersed, creates steam that performs work, but part of energy is dispersed. And there are three sources of energy. The three sources of energy was account for all the work of the system. The sources are gravitation, internal forces within the earth, and the solar radiation. The last one is the significant for ecosystem. The solar radiation, which originates from sun, is the source of energy for life and is what sets the ecosystem behind other natural systems. And moving on to the next slides, which is the energy flow in our ecosystem. Due to an indirectional flow of energy, the behavior of energy in an ecosystem is called from the energetic point of view. Energy flow is explained as under first as the efficiency of the producer in absorption and conversion of solar energy. Next is the use of the above said converted chemical form of energy by the consumers. The third one is the total input of energy in form of food and its efficiency of assimilation. Then the fourth is the loss caused through respiration, heat, excretion, and etc. Then the last one is the gross net production. Those are the explanation of the energy flow in our ecosystem. Then there is a single channel energy model. It was proposed by Lindemann in 1942. He was the one to propose the community energetics approach or the dynamic model to ecology, which enables an investigator to compare the relative rates of which different kinds of concerning energy flow through one of his examples is comparing ratios of lift to leather deposition on the forest floor. He concluded that the rates of lift production are higher and those of litter accumulation are lower in the tropics than at the higher latitude. That brings me to the end of my presentation. Thank you for the attention. To answer any questions you might have. So, that's all for today. Thank you.